Hello, my name is Papri Ghosh. I am from CSE DS department, data science department from Haldia Institute of Technology. So today we are going to continue our last session. So our problem session. So design a minimal DFA that accepts all string over the alphabet A, B, where every accepted string W must be like mod of W is 3. Mod of W is 3. What is the meaning of mod of W? Mod of W means the length of the string will be 3. Exactly 3. So, minimum string, it can be AAA, it can be triple B, it can be ABA, ABB, BAB, BBA. So, the length of the string will be 3. So, Q0 So, our problem is that the length of the string will be 3. It can start with A or B, it can start with anything, or it can end with anything. Our problem is the length of the string will be 3. So, that's why if we apply AB on Q0, it will go to Q1. If we apply AB on Q1, it will go to Q2. If we apply AB on Q2, it will go to final state. So, that's the length of the string exactly. Now, mod of W less than equal to 3. Mod of W less than equal to 3 means the length of the string will be at most 3. Okay, will be at most 3. Okay, that means at most 3 means our epsilon is accepted. Okay, epsilon is accepted, A is accepted, B is accepted, AA, AB, BA, BB will be accepted, and AAA, triple B, ABA, ABB, AAB. Okay, will be accepted. Which one is not going to? Okay. One problem. When we are talking about the exact the length of the string, exactly 3. So, what will happen if our string is greater if the length of our string is greater than 3 for this automata? It will not accept. So, it will go to the reject state. It will go to the reject state. Okay, same. So, what will happen if if the length of our input string, if the length of our input string is greater than 3, it will not accept. So, again, it will start with Q0, and here we have applied epsilon. Epsilon means initial state is final state, because null string means we are not giving any input symbol. That means without giving any input symbols, we are going to reach our final state. That's why our initial state will be final state. If we give A or B, then it will reach our final state. Again, if we have applied If here, that means the length of the string will be 2. It will be accepted. And again, the length of the string will be 3. It will be accepted. And if the length of the string is greater than 3, then it will go to the rejected set. Where Q3 is our rejected set. So that's it. Now the length of our string is at least 3. That means the length of our input string is at least 3. So it can be greater than 3. Okay. So here, that means A will be invalid, B will be invalid, 3 will be double A, double B, double A, double B will be invalid, and triple A, triple B, 4A, 4B, ABA, AB, BA, it will be accepted. So again, we are going to accept triple A and triple B. Triple A and triple B. After that, whatever combination of A comma B will be accepted, because here we have told A epsilon the length of string the length of the string when A 1, it will not be valid, it will be invalid. The length of the string when the length of the string is 2, it will be also invalid. When the length of the string is 3, it will be accepted, and after the length of string at least 3. So if the length of the string is greater than 3, it will be accepted. So after the triple A or triple B or any possible combination of AB, after we are having 3 times the possible combination of AB, whatever input symbols we are going to apply on final state, it will be the final state. It will be on final state. Okay, it will not hamper our DFA. So that is for the length of string is at least 3. Okay, I think you have understood. Right? We are going to the next problem. Design a minimal DFA that accepts all strings over the alphabet sigma equal to E comma B, such that every string accepted must contain exactly 2 X. That means in our input string it must contain exactly 2 X, not less than 2 or not greater than 2. We have to contain exactly 2 X. The number of B can be anything, but the number of A will be 2. So, must contain, that means our language can be minimum language will be double minimum language. Okay. And AB, AB, BA, anything. So, apply B on initial state, that means it will stay on initial state. Okay. So we have applied A and B on Q0. Then if we apply B on Q1, then what will happen? It will stay on Q1 because we have to contain exactly 2s, but we can have any number of B's and in any position. We can contain B in any position. We can start with A, we can start with B, we can end with B, we can keep B in middle position, wherever we want. Also, wherever we want, we can put A. We can keep A, but we must have to contain exactly 2s. So we have applied A and B on Q1, and if we apply B on, there are no problem. But if we apply A on a final state, it will go to the gradient state. Okay. Now we are checking. If we apply A, it will go to the final state. AAB, AAB, it will stay on the final state. ABA, ABA, BAA, BAA. Okay. And you can check with AAA. AAA is not containing BBBBB, A, BBBBB, A. If we apply A, it will go to the gradient state. So that is our solution for the minimal DFA, which are going to accept every string accepted must contain exactly 2s. Now, design a minimal DFA that accepts all strings over the alphabet sigma equal to A comma B, such that every string accepted must contain at least 2s. Okay. At least 2s. That means we can have minimum 2a. We can have a, and we can have the number of a's greater than 2. Okay, but not less than 2. So minimum language will be again here AA, and AAA will be accepted. So minimum will be AA. So if we apply B on initial state, it will not hamper our DFA. So we can stay on our initial state. And if we apply B on middle position, so again it will stay on Q1. If we apply B on final state, it will stay on final state. But if we apply A or here, so also it will stay on final state. Because we must contain at least 2A. Okay, at most any number of A's. Okay, so that's the result. Okay, now design a minimal DFA that accepts all strings over the alphabet A comma B such that every string accepted must contain at most 2A's. That means at most 2A. So if we contain no A's, it will be accepted. If we contain at least one A, it will be accepted. If we contain at least 2A's, it will be accepted. If we contain more than 2A's, it will not be accepted. Okay? So minimum language can be external. Right? We are going to contain no A's, no B's. Okay? So epsilon will be accepted. A will be accepted, B will be accepted, and double A will be accepted, and any combination of B will be accepted, and triple A will not be, sorry, triple A will not be accepted. A, B will be accepted. So our initial state will be final state because we are using here if channel. If channel means our initial state is our final state. So then, if we apply A or B, it will be accepted. If we apply B here, it will be accepted. If we apply A here, it will go to the final state. If we apply B here, it will stay on the final state. But if we apply triple A, then it will go to the rigid state. And it will stay on the rigid state. So Q0, Q1, Q2, and Q3. So any possible combination of B will be accepted here. So B, 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 B. Okay. Any A will be accepted, null string will be accepted, B will be accepted, double A will be accepted, BAB, combination of BAB, BB, AA, BBA will be accepted. More than 2 A's will not be accepted. That's why triple A, more than 2 A's is not accepting. So that is our DFA for where accepted string must contain at most 2 A's. Now we are going to solve the next problem. So it's a GATE question from 2006. So it is in the automaton below. This is the start state. This is the start state, and T is the final state. And consider U AB 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 B A B A B and W A A B B. Which of the following is true? Then our option is the automaton accepts U and V but not W. Now we are going to check this. So A B A B A B. So if we apply A on A's, it will go to this state. A, B, A, B, A, B. Right? This is not accepting. This is not accepting. So next is B, A, B. So B, A, B is not accepting. A, A, B, B. A, A, B, B. So also it's not accepted. So the automaton rejects each of U, V and W is the answer. Right? Now again this is another question. Consider the following table of an DFA. The final state is Q4 and which of the following string will be accepted? We can solve this question by drawing the state transition diagram. So this is Q0. If we apply, the initial state is S or start. So start is our initial state, and if we apply A on start, it will go to Q1, and B on start, it will go to Q0. Okay. If we apply A on Q0, then it will go to Q1, and B on Q0, it will go to Q0. If we apply A on Q1, it will go to Q2. And if we apply B on Q1, it will go to. If we apply A on Q2, it will go to Q3. Sorry.